Again, we're going to look some more at linear functions. This leads into our next unit. Our next unit is all on linear functions, interpreting the graphs. So first of all, the x-intercept. The x-intercept is where your graph crosses the x-axis. Algebraically, you're going to always know that wherever you have an x-intercept, that your y-coordinate is going to be 0. So if we look at this one where the x-intercept is at 8, if you labeled that point, does it make sense that your y-coordinate is always going to be 0 no matter where I label an x-intercept? Everywhere along the x-axis, your y-coordinate is always 0. And with your y-intercept, anytime you label a point on your y-axis, the x-coordinate is always going to be 0. Now the y-intercept and the x-intercept, when your graph is representing a real-life situation, like we did with the tying of the knots, it means something important. So your y-intercept was how long your string was when you started with, and as we tied knots, our x-intercept would mean that there'd be no string length left anymore, which you would have tied so many knots that you possibly couldn't tie any more knots. So they both have something very significant in their meaning. Height of a burning candle changes with time. So we've got an x-intercept and a y-intercept. What is our x-intercept? Where does it cross the x-axis? At 45. What is our y-intercept? Looks like we're going by 2's, so we should write units here, 45 minutes. What does it represent? When your house is going to burn down? Possibly, right? When there is no candle left. At which time you should blow it out. Otherwise it could be very dangerous. What is the y-intercept? 10 centimeters. What does this represent? The initial height of the candle. Before you lit it, it was 10 centimeters tall. Well, it's going by 2's. So we look at our scale here. If we have to be careful because you get very tempted to count by 1's, because often on graph paper you count by 1's. But we have to make sure we look at our scale and say, what is everything going by? And here it's going by 2 centimeters. What are the domain and range of this function? So looking at our domain, that's our x values. Do we have a smallest x value? Yes, 0. Do we have a biggest x value? Yes, 45. So in set notation, we could write it as 0 is less than or equal to x is less than or equal to 45. Or in interval notation, we could write it from 0 to 45 with square brackets because both 0 and 45 are included. Our range, is there a smallest y value? Yes. The smallest height is 0. And the highest y value is 10. So it goes from 0 to 10. Oops. This graph represents the relation between the cost of an electrician's house call and the time that he worked. So you have problems in your house. You turn the switch on, and it's still dark. So normally people would switch the bulb, but no, you phone an electrician. And you get the electrician to come out to see if they can figure out why there's no light in your room. So the electrician comes, goes, your bulb is burnt out, takes him 30 seconds to put a new bulb in, and he charges you how much money? $60, because it basically took him 0 time whatsoever. What's the y-intercept? That's $60. What does it represent? What would you call that?
Cost to hire him?
The cost to hire him? Sure. Cost to hire him. The base cost that you pay, the service call cost. Sometimes they call it that when you get a bill. So, or they say, we're coming out to your house and we're going to charge you $60 just for driving there. And a lot of companies do that sort of thing. They have a service call cost. You want us to come check out why your room is dark? It's going to cost you $60 just for us to get there. And then it's going to cost you more. Is there an x-intercept? No. Why not? What would an x-intercept be? What would it mean?
$0.
When it is free, right? It represents when it is free. The cost would be $0. And unfortunately, this is not going to be free because there's a $60 service cost. It'd be nice, you say, oh, if you just stay here for 2 hours, then my bill will be free. But I'm already changed the light. No, here, have a cookie. No, there is no, and most businesses don't work this way. The longer it takes, the cheaper it gets. No, the longer it takes, the more expensive it gets. Can we figure out from here how much the electrician charges per hour? Okay, we've got 2 points. We got 2 points. It goes up to, it's going by 60, so it's $180 here. Okay. How much has the price gone up in 3 hours? In 3 hours, the price has gone from $60 to $180. The price has gone up $120. How much would it go up in an hour then? Well, 3 hours it goes up $120, $40. So he charges $40 per hour, which is probably might even be cheap for an electrician. A lot of tradespeople charge $50, $60 an hour, plus their initial call. So it could be a really good job if you're looking at, if you like fixing things and working with tools. You can make a lot of money as an electrician or as a plumber or a specialty trade like that. Light bulb switcher outer, I don't know how many people will hire you if that is, I'm not an electrician, but if your room is dark and you don't know what to do, for only $30 an hour, I will fix it. Sketch the graph by using the x-intercept and the y-intercept. Let's find them one at a time. To find a y-intercept, the key thing is we know that x has to be equal to 0. So we look at our equation and we say, in our equation, if x is 0, So I keep the equation the same, except I replace an x with 0. What would y equal?
0.
Well, let's look. What's 2 times 0? 0. So on this side, would you agree that I have minus y? On this side, I'm going to have 4. If minus y is equal to 4, what's y going to equal?
Negative.
-4. So we go to our graph, and we now found out that our y-intercept is at 0, -4. What do you think we're going to do to find our x-intercept? What do we know? What do we know about our our x-intercept? That y has to be 0. So we go to the same equation. And this time we replace the y with 0. In which case, on this side, you would get 2x is equal to 4. How do you solve that? Divide by 2. And so we get a y-intercept, an x-intercept at 2. Go to our x-axis. We can label that point 2, 0. It's a straight line. It's a linear function. Connect your dots. Draw arrowheads on the end. And you've drawn your line using just the intercepts. A couple of things, okay? This question said, sketch the following linear functions. So we knew that they were straight lines. Later on, you're going to be asked to just, can you look at this and tell it's a straight line? How do you do that? Well, straight lines can always be rearranged. Remember we talked about this mx plus b form? Straight lines can always be rearranged to look like that. In this equation, could you get the y all by itself? Probably be easiest if you move the y to the right-hand side. Could you see that if I add y to both sides, I'd get 2x equals y plus 4. And then if I subtract 4 on both sides, I'd get 2x minus 4 equals y. So I could rewrite this equation as 2x minus 4. What did the b stand for? No. The y-intercept. Is our y-intercept at minus 4? Can you see if you plugged in 0 for x, it would be really easy in this way to find your y-intercept. And it's minus 4. The 2, what did that stand for? Sorry, I'm teaching you the next unit a little bit early, because this is what the whole next unit, that stands for our slope. And so our slope is our rise over run. If I change 2 to a fraction, 2 over 1, can you see that this line goes up 2 over 1, hits a point, up 2 over 1, hits a point, up 2 over 1, hits a point, all the way along. So our slope shows up in the graph as well. So I'd like you to try this one on your own. In fact, I want you to try the next 2 on your own. You need to first find your y-intercept, and then find your x-intercept by plugging in 0 in the correct spot, and then draw those points and connect your dots for your line. Let's check how you did. For your y-intercept, plug in 0 for x, which would give you minus 2y equals 12. Divide by minus 2, your y-intercept is at -6. To find your x-intercept, plug in 0 for y, which would give you 3x equals 12. Divide by 3. Join your points, and you have your line. One thing you could do on this one is see, could you rearrange this into y equals mx plus b form? So I'll write it for you, but it's a challenge. See if later, could you rearrange that equation to get y by itself? So you'd have to move a few things to different sides of the equation. You're going to have to divide by 2 eventually to get the y by itself. And you should have a b value of -6, because that's our y-intercept. And can you see that this one goes up 3 over 2 to hit another point, up 3 over 2 to hit another point? Our next example, find our y-intercept, plug in 0 for x, and remember that f of x and y are the same thing. One is in function notation, one is just in, I guess, regular notation. So if you're finding a y-intercept, you're plugging in, and you can just, if you want, you can change f of x to y. 4 times 0 minus 3. So your y-intercept is at -3. And to find your x-intercept, plug in 0 for y. In this case, we'd plug in 0 for f of x. How do I get x by itself? Add 3 to both sides. Divide both sides by 4. And you get x equals 3 over 4. So in this case, our x-intercept wasn't the prettiest point. 3/4, comma 0, had a fraction in it. It's not wrong. You can estimate where that fraction is, draw the point just like we did, connect them and draw your line. Okay? Can you see that this one's already in y equals mx plus b form? And your m is 4, which is the same as 4 over 1. So one of the things that we're going to use in our next chapter for graphing is sometimes it might be, oh, the y-intercept was easy. The slope is 4, so that means if I do a rise of 4 and a run of 1, I'm going to get to the point 1, comma 1. Maybe that's a better point to use to draw my line. Because as long as you have 2 points on a line, you can draw a straight line going through them. Which graph corresponds to a rate of change? And remember that rate of change is another way of saying slope of 1/2 and a y-intercept of 6. Well, they both have y-intercepts of 6. It would sure be nice if one didn't have a y-intercept of 6, because then we could right away say what it is. So we have to use slope. And what do we know about slope? Slope is equal to the rise over the run. And in our case, the rise has to be 1, the run has to be 2. So if we take a point on our graph, the starting point here, we have a rise of 1, which means goes up 1. A run of 2 over 2. Go to this one, a rise of 1, a run of 2. Which one matches up? The second one. Okay? The second graph has a slope of 1/2. We can show that. The first graph When the line goes down like that, we need a negative in there. To have a rise of -1 would mean that it goes down 1 first and then over 2 to the right. Sometimes the rate of change or the slope that's given isn't easy to draw on the graph. Because on this one, my time scale is going by 5s, and my distance scale is going by 50s, and I need a rate of change of -5. So it might be that you find the slope for each graph by taking 2 points that are on the graph. If we look at graph A, we have these 2 points. If we draw a rise and a run, well, here I'm going down 100, so we would show that by -100. We're going to the right 20. So the slope of this one, the rise is -100, the run is 20. This simplifies to -5. So we already know that this is the right answer. It has a y-intercept of 100 and a slope of -5. If we took 2 points on the second one, we have a run of, whoops, too far, a run of 10 and a rise of 50. The slope of this one, the rise is 50, the run is 10. This one has a slope of +5. So anytime your line goes down from left to right, this would be like if this was a mountain, you're going downhill. Then we would say going downhill has a negative slope. This one I wouldn't suggest skiing because it would be going uphill. It would be tiring. Unless you like that cross-country skiing going uphill all the time. That one has a positive slope.
It says justify your answer. I'm just wondering, could you just say
So as
negative, so it's clear?
that would be cheating a little bit. It might have been that the answer is neither, right? So since the slope is -5, this is the answer. All right, 2 questions to go. Example 6 and then example 7. This graph shows the cost of publishing a school yearbook. The budget for publishing costs are $4,200. What is the maximum number of books that can be printed? So if we look at this, it forms a linear function. We could estimate from our graph where 4,200 is, go straight across, and go down, and I would estimate it from the graph to be 175 books. However, if we want to be more accurate, we could use the equation. Can you look at this equation and can you see where the y-intercept is? The y-intercept is at 500. Just for signing up that we'd like a yearbook, they're going to charge us $500 for the setup fee. Then the slope Well, we could go from this point to this point. We go over 50 and we're going up 1,000. Slope is rise over run is $20. What does that mean? That means if we go over 1, we're going to go up 20. Right? Because we could write that as 20 over 1. Going over 1 means you make one more yearbook. Going up 20 means it's going to cost you $20 more. So if we think about y equals mx plus b, the slope is 20, the y-intercept is 500, we could write an equation for this. And using that equation, if the maximum cost is 4,200, the y is your cost. You could plug that into the equation and then use your algebra skills. Can you get x by itself? So if we subtract 500 on both sides, we get 3,700 equals 20x. Divide both sides by 20. How close was our estimate? Pretty close. But the actual amount of books you could purchase is 185. So our graph gave us an idea, but unless we were perfectly drawing across from 4,200, my dots seem to go up and down and a little bit over, right? And then going straight down from there, we estimated at 175. We find out later that it actually was 185. Have to change the French at the top. Cost of an electrician's house calls. So again, this one is a similar question. Use the graph to estimate and then find the actual equation to see how close your estimate was. And I'll leave this one for you to do on your own.